Hi, good afternoon, everyone. Thank you for coming to the session. This is Building Lightning-Fast Apps with Platform Cache. And as the title might suggest, today we'll be talking about Platform Cache. Quick introduction. My name is Danny Chang, and I'm an ISV tech evangelist here at Salesforce. And so as part of my day job, I work with our ISV partners that develop on the App Exchange or other apps built on Salesforce and make sure that they're successful when building on our platform. I'm also on Twitter, so after the session, if you have any questions regarding Platform Cache or maybe working as an ISV partner, please feel free to follow me and @mention me on anything that you might have questions about. Let's start with the forward-looking statement side. Please remember that Salesforce is a publicly traded company, and when making your buying decisions, please do so based on what is generally available today and not based on any forward-looking statements that I might make during this presentation. And this seems like a good question to ask when you have a session about Platform Cache is, what is Platform Cache? Well, before we get into Platform Cache, let's get into the concept of what caching is. Just by a show of hands, does anyone know what a cache is or what caching means? OK, majority of the room, that's good. But just for those that might not be familiar, caching is a cache is a component that stores data temporarily so that the next time you request for that data, it's stored locally or somewhere closer and faster to access, so that next time you need to access it, it'll be a lot faster to do. And what does that mean in terms of Salesforce? That's data for your Salesforce users. So there might be results from an API call that you're making to an external system, or even a SQL query that you might make. And then that takes a long time, or in terms of time and hardware resources. But when it's stored locally, it's a lot faster to get back to. And there's two main flavors of Platform Cache, or actually there is only two flavors of Platform Cache. One is Session Cache, and the other one is Org Cache. We'll get into more details on the next slide, but all you have to remember is that they're both very similar, except the Session Cache is tied to a user session. So when the session expires, all that data that was in the cache will also expire with it. Just sort of to draw you a diagram of how that might look, without Platform Cache, what would happen if a user is trying to get data from a database or an external system is you're going to make a round trip to the database and back. And that might take a long time depending on what kind of system you implemented or what kind of org you have. To avoid that kind of ordeal and make it make performance a little more dependable, Platform Cache is stored within the org itself. So next time if the user is trying to query for the exact same record, you're not going to need to make that round trip. Or you're not even going to need that external system or the database, because everything will be looked up locally within Platform Cache. We'll kind of go into this in the demo further, but that's the general idea of how a cache works. And again, as I mentioned before, Session Cache and Org Cache works almost identically, except again, is tied to a user session. So when the session expires, or a maximum of 8 hours, it'll last in the cache and it'll disappear. For Org Cache, it's a little different. Org Cache data is available to everybody within the org, and it defaults to 24 hours before it expires. Or you can specify the time to live, TTL, and the maximum of that is 48 hours. So if you specify to live for up to 48 hours, after that, the data will be gone. And getting into a little more detail about how we implement everything under the hood, we implement something called the last recently used algorithm. Again, if you're familiar with the concept of caching, this might seem familiar. But what that means is that if you have 5 megabytes of cache space and you have 4.999 megabytes full, when that last byte comes in, we are going to kick out the last recently used data that's in the cache. So let's say you have data from 8 hours ago compared to 7 hours ago, but that data you got 8 hours ago was used a minute ago compared to that data from 7 hours ago. That data from 7 hours ago will get kicked out before the data from 8 hours ago. So whatever was last recently used will get kicked out, so that the cache still works even if you think it's full. We'll keep filling it up with whatever new data that you might need. And moving on, what are we exactly storing in the cache? They're key value pairs in the form of a string. So the key is a string, and the value is a string. And so if you want to, sorry, there's a little low resolution. But for example, if you want to store data about a particular user, the key might be first name, string first name, and the value might be bugs, or in my case, it'd be Danny. Last name, Chang, and these key value pairs will be stored underneath. Again, when we go through the demo and when we walk through the code, it'll kind of be a little more intuitive. And finally, we do offer the cache builder interface. For the sake of the demo, it's very simple, so we didn't implement that. But we do offer it. And when you actually get to implementing the logic in your org, it's a lot easier to organize your code and logic. So we highly recommend that you use that. Okay. So we learned about what Platform Cache is and what do you have to do if you want to get started using Platform Cache. And how accessible is it? Well, the good news is that if you have Enterprise, Unlimited, or Performance editions, we already give you free default allocation. So that for Enterprise and Performance editions, you get 10 megabytes. And for Performance editions, that's 30 megabytes. So if this is the first time you're hearing about Platform Cache, but you know your company or your users have one of these editions, you can get started using today. And we also offer something called partitioning. This is a feature that you can go into setup, and you can partition your cache to be however you want it. Maybe you want 5 megabytes for session cache and 5 megabytes for org cache. Or maybe you want 5 megabytes for app A and 5 megabytes for app B. You can go into the UI, and it's very simple to do. You will name your cache to whatever you want. One will be called Danny's cache, and one will be called Salesforce cache. And you can put different data into different caches depending on how you want to implement your logic. And finally, if you don't have any of those editions, or maybe you do, but you want to try out a proof of concept, you can always spin up a developer edition org and sign up for a free trial. We'll give you 10 megabytes for free. You can kind of draw out your proof of concept, maybe pull in some test data, and see how much of a performance gain you might gain from Platform Cache. And then maybe you can show it off to your friends, your colleagues, or your boss. And if everything works out correctly, you can implement it in your sandbox and eventually your production org. And let's quickly jump into a demo. I'll be talking and moving around at the same time. And I hope I don't slip up, but here we go. Okay. So what I did was I implemented an org cache. And the story here is that we own a banana stand. And we have a very complex model based on historical data, weather data, and whatsoever. And we have this computation being done in Heroku. So what we're going to do is we're going to make a round trip to Heroku and back by inputting a date. So here, okay. So for example, if we want to calculate for April 1st, once I hit calculate, we're going to send this data over to Heroku. It's going to take some time, and it's going to come back. Let's see how long it takes. So 1, 2, it's going to take a couple seconds, 3, 4 seconds. Again, it's a very complex model, so this is going to take a while. And nothing is in the cache at this point. The cache is completely empty. So this is going to take a lot longer as compared to, oh, and it errors out. Let's refresh the page one more time. We tried April 1st, so let's try April 2nd this time. Calculating. All right. So we're going to need 64. So what we did just right now was not only did we get the result back from Heroku, we also warmed up the cache, meaning next time you try to look up this data, April 2nd, 2018 will be in the cache for up to 24 hours. So when we need to do that calculation again, it'll be a lot faster. But just to make sure that everything's working properly, let's try another date. It's going to take a long time and come back. You need 60. But when we go back to April 2nd, like I mentioned, the cache is warmed up, everything's in the cache, and this should be a lot faster. Yep, it was almost instant. So it's a lot of performance gain to be had, depending on how complex your org might be, or how well you implement your logic. But yeah, overall, there will be definitely a lot faster performance improvements. And I did mention that this is an org cache and not a session cache. So what that means is if I sign out, and we try to sign back in, theoretically, everything should still reside in the cache because it hasn't been 24 hours since we made that call, and we stored that in the cache. But here we go. All right. And what was the date? Everyone remember? April 2nd, right? April 2nd. It shouldn't take 4 to 5 seconds like it did last time. It should be more like a second. There you go. So everything's still in the cache, and you can kind of see that. And let's say you've already implemented this logic in your org, and your users start using it. But how do you know it's actually being useful? We also offer a diagnosis page from setup. So from the same org, you're going to go to Platform Cache. And you're going to see how much of the cache space you're using right now. The capacity is breakdown. So for example, we only have one trial cache space right now, which is 10 megabytes. And we only have one partition right now called local.democache. And when you want to refer to that local.democache in the code, this is what the Apex class would look like. You're going to initialize the org partition here. You specify which partition you want to work with. And putting the value in the cache is very simple. It's just one line, org partition.put. The key in this case would be the model state, and the value will be the amount of bananas that we need. And getting the date is pretty simple too. From the cache, we're going to do orgpart.get. You give it a key, and it'll return a string. Or if it doesn't, it'll be still null. We're going to discuss how important it is to design for cache misses. But you have to have this null check, or else your app will not perform the way you want it to. And and if the cache wasn't warmed up, we're going to have to go into this else clause, where we send this GET request to our Heroku app. And then afterwards, we're going to get that value back, put the value in our cache, and return the amount of bananas that we need. The reason why it was so much faster when the value was already in there is that we get to skip this entire else clause if the cache was already in there, if the value was already in there. All we have to do is go here. Since it's not null, we're going to return the value. And that's why it's so much faster to do this over making that round trip to Heroku and back. So that was a quick demo. If you have any questions, I'll be around for 5-10 minutes after the session. And some special considerations that you might think about when you start working with Platform Cache. And some best practices. One is that you have to decide what you want to cache. There's some recommendations that we make. Top use cases would include static data. So you don't want to store something like a stock's price, where it's constantly changing. And every time a user wants to look that price up, you're going to have to make that round trip over and over again anyways. So static data is one thing we recommend. Another is frequently used data. If it's only used by once per user per day, but you have 100 or 1,000 people in your org, that's a lot of time you'll be saving back over on the aggregate level. So frequently used data and static data are two main cases that we recommend. Of course, your org will be different and your users will be different. So you have to get creative on how you might do that. Secondly, you might want to consider, maybe you need to store some account records, but do you need every single field within the record? Maybe your salespeople only need the account name and the email address. Maybe they don't care about the revenue or the number of employees at that account. So try to minimize. Cache space is expensive. So try to minimize what you're storing, but at the same time, make sure that's what exactly your users need. Secondly, storage patterns. We won't tell you how to code your app, but we do recommend that all the logic related to the cache should be within one class. And that's because if you have 2 or 3 multiple places writing to the cache, you might be overwriting things. And so even if you have, let's say, 5 megabytes of space, you might really be working with 1 megabyte because everything's getting overwritten over here. So that's one logic that we do recommend. Another thing is I mentioned before in the demo, you should definitely design for cache misses. Because cache storage space is more like the icing on the cake, and the app is the actual cake itself. If you don't have the icing, you still want to be able to eat the cake. Similarly here, even if you don't have the cache space, your users should be able to use the app without having to crash out or error out. So storage patterns, 1, design for cache misses, and 2, try to have all your cache logic within one class. And lastly, cache larger items. What I mean by that isn't, I don't mean, like I mentioned before, storing an entire, every single field within an account record. What we mean is, because there's a lot of serialization involved and a lot of overhead involved with storing each key value pair, try to, instead of having one account record, try to have a list of them. So that when you fetch it, there's a lot less overhead involved with that cost, and so it'll be a lot faster. And maybe if you just need that one record within that list, you can iterate through it with using your Apex logic or whatever other flows that you might have, and try to work from there. OK, last slide. And if you don't remember anything that I've talked about for the last 15 minutes and you have to go back to work tomorrow, I just want you to remember these 3 things. One is try the Trailhead. It's very comprehensive, and a lot of the content I covered is actually on the Trailhead, but it'll be very interactive. And so you definitely go try the Trailhead, where they'll also tell you to sign up for the free trial. For the sake of the Trailhead, they're going to make you code a simple app, and they'll have all the code given to you. But if you have a use case and you already have that org with the trial installed, you might as well try using it for your own org. And finally, join the Trailblazer community. We have the product managers on there. We have the engineering teams on there. We have community users probably who have already used Platform Cache before. So if you have any questions or if you have features that you would like to see in an upcoming release, that's the place to go to post. And someone from our community will be more than happy to interact with you on that level. And with that, it was a very comprehensive topic, but we only had 20 minutes. I hope you guys got a feel for what Platform Cache might be. And I hope you guys enjoy the rest of the Trailhead DX. Thank you.